Welcome to 5-2, substitution and general power rule. General power rule we've kind of dealt with already, but we'll play with this within the realm of substitution. So I always like to start these with taking a derivative because we're doing that whole process backwards. So it helps to think, okay, if I were to do the forward of this, the regular, what does that look like? So our function is f of x equals x squared plus 1 to the fourth power. If I take a derivative, I use the chain rule. So we get f prime of x, bring the outside function times the inside function, the derivative of the inside function. Okay, so we can clean that up. Gives me 8x times x squared plus 1 cubed. And that's how we'd find its derivative. So another way we can think of this as, let's turn it into blue. We did this a lot with our exponential and logarithmic functions. We turned them into u problems. So if I were to substitute my u equals the inside, well, what's the derivative of u? We'll call it du. It's 2x. Okay, so now equals, 4 u to the third times du. Sometimes we say u prime. We're going to use du a lot, so we use that. And we want to go backwards now, turn it into what we want. We get 4x squared plus 1 cubed times my du, which was just 2x. Clearly, I'm doing this for a reason. But that's the idea we would go if we were to take a derivative. So now we're going to use that same idea backwards. This whole section is backwards. Chapter is backwards. So what we want to do is look for something and its derivative in our problem. And hey, look, it's a very similar problem to what we have above. Not exactly, but close. So I see this is an inside function. And if I were to take the derivative of that, it's just 2x. So I'm going to say u equals x squared plus 1. I leave the cube off because we're just looking at the inside part. And if I were to take the derivative of that, we know it's just 2x dx. Don't forget your dx. Okay, so rewrite my problem. Take one step to reorganize it. Okay, now I have my u, and this is my du. So I never say equals because technically it doesn't. U cubed du. Oh, we know how to take the derivative of that, or the antiderivative of that. This is just going to be 1/4 u to the fourth plus my constant. And we can't leave it like that because our original function was in x's, not u's. So another arrow, sorry, this is going to turn into 1/4. My u was x squared plus 1 to the fourth plus my constant. And this is my f of x. U substitutions, these are lovely if we can find them. And sometimes we can almost find one. So we manipulate it a little bit. You know what? I wrote that in a way I didn't like. It's been a minute since I've done U subs, so I forgot my values. Okay, we're going to do a bunch of these. So do you have an inside function and its derivative, or its derivative if you squint? In this case, yeah. Let it go back to you. So I'm going to say my u is 3x minus 1. Take the derivative of that. Hey, there's my du. This is practically the same problem I just did. 1/5 u to the 5th plus my constant, and substitute back in, which turns into 1/5 3x minus 1 to the 5th plus my constant. Now you could have gone and expanded the original to get rid of that to the 4th power. And when your powers are little, that works okay. But you can see our powers are not always going to be so little. So to the 4th is not great, but it could be worse. You get up to the 10th, and that's just nasty. So you're better off expanding them a little bit, or using a U sub rather, and making them nicer. So that's what we're going to do. All right. Well, good. I gave myself lots and lots of space on this one. This one's not necessarily as obvious as the last. So when I have a case like this where we're multiplying two things, I look for the function of the higher power. So the degree of this little function is 2. The degree of the other one is 1. So that's the higher power. That's what my u is going to be. And sometimes it takes a little guesswork to get there before you kind of get the feel of it. So we'll see if this works. Spoiler alert, it's going to work. I forget to write my d. No, I didn't. Okay. All right, take the derivative of this, 2x plus 1 dx. Hey, there it is. Cool. This one's really straightforward. We get 1/2 u squared, plug it back in. So which gives me 1/2 x squared plus x plus my constant c. And this is a case of, whoops, I forgot my 2, didn't I? If you would have expanded this out, we can get to the same place. Your just final answer is not going to look the same. Back when I first learned calculus, we had book problems and we could look in the back of the book. And the challenge was all, if the book solved your problem in a different way than you did, your answers aren't going to match. So yeah, that was always good times. Okay. This guy again looks really scary, but look in your denominator and I see, okay, the derivative of my denominator, ignoring like the inside of my denominator, ignoring the other part, that's going to give me negative 4x. I see that in there. And worst comes, try out a couple things. And sometimes you have to rearrange your problems a little bit. There's my du. Perfect. Gives me 1 over u squared du. I don't like that. U to the negative 2 du I like a lot more. Add 1, which gives me hang on, sorry. U to the negative 1 times 1 over negative 1 plus c, which is just negative u to the negative 1 plus c. I can rewrite once more. Final step, plug your u back in. And you're done. Okay. This one is leading us into our next section. So I have something in its derivative, sort of. So if I look at this, if I say my u is 3 minus 4x squared, my du is negative 8x dx. I don't quite have that in my problem. So we can either manipulate the problem a little bit or manipulate my du. It's really all the same. Let's manipulate our du a little bit. So if I were to take this, I want to get x dx. I don't quite have that. But what if I multiply both sides by negative 1/8? I get negative 1/8 du equals x dx. So we can manipulate our equation by multiplication division to get what we want. So now we have it in the format we like. We can substitute this in. Squared times negative 1/8 du. I really don't like that. And here's the exception where I throw something on the outside. Fractions kind of hurt your brain sometimes. So if I can just kind of toss a fraction on the outside and momentarily forget about it when I do the rest of the problem, I'll do that. It doesn't change your final outcome. Oh, there's another one like this. Okay, take the antiderivative. I get negative 1/8 times, add 1. Oops, not xu. It's constant. And we know that is negative 1/24 u cubed plus c. Plug back in. Negative 1/24, 3 minus 4x squared cubed plus c. All right, double checking my math. It looks solid. We could have manipulated the function instead of the du, and that's fine too. Both methods are equally valid. It's just a matter of which way makes more sense to you. I can't remember which way I originally did this. I did it backwards as to most people do it. So I think it was the other way. I think this is the simpler way. Okay. Again, I see something and almost its derivative within a constant. So there's my u. Then my du is just 2x dx. And I almost have that on the inside. So I have a 5x dx. If I multiply both sides by 5/2, yeah, that's okay. Hey, it matches what's in my function. So we're good. We can plug this in for our 5 dx. So this turns into, I'm going to throw u on the outside, square root of u du, which is 5/2 u to the 1/2 du, which gives me 5/2. Okay, add 1 to the exponent, not subtract 1. U to the 3/2 times the reciprocal equals 5/3 u to the 3/2 plus my constant c. And now I can plug my u back in. Is that my last problem? Oh, look at that. I forgot to say that was done. Which gives me 5/3 times x squared minus 1 to the 3/2 plus my constant. And that's that. I do believe that was the end of my problems. Yep, no more. So, yeah. You can't add or subtract stuff, but you can multiply or divide by constants to manipulate your problem into a format you like better. So don't be afraid to try things. And if they don't pan out, that's okay. And you'll start to recognize patterns as you go. And I swear it gets easier the more you practice. It may never be easy, but it'll be easier. And yeah, just keep practicing some of these. If you need more resources, let me know. I can find you some. If not, there's tons on the web of practicing these sorts of problems and other tips and tricks. I've given you my favorite tips and tricks. I've given you the things that I find students find most helpful, but not everybody's the same, so you may be a little different. All right, I'm going to end this here and I'll see you next time.